All right, hello everyone. Welcome to the talk called Call Me Back Postgres. Today we're going to talk a little bit about some native function that Postgres offers in terms of triggers and their listen, notify pub scheme. To get started, a little bit about me. My name is Ifat Ribon. I work for a digital product agency based out of Chicago. I live in Chicago as well. Principal architect there. We are hiring, so if you are interested in that, let me know later. I live in Chicago, like I said. I like to run. I've been playing lacrosse for most of my life and played in a lot of international tournaments. So a little bit about me, and you can find my social media and or developer media down there at the bottom. So with that, this talk is going to be kind of in the style of a case study. So as an agency, we work on a lot of client projects. One particular project that I had kind of led me down this path to learn about Postgres' functions and use them for a data sync service. So I'll kind of give a little bit of background just so you know what I'm talking about. We'll talk about what those sync approaches were that I explored. We'll actually go into some of the concepts that I've been teasing and wrap up with sort of like a system design. And I'll point out some resources at the end. So with that, to start off, the client project that I was working on that involved this is a Salesforce client. We work a lot with Salesforce integration and things like that, and they're hosted on Heroku. But it's okay if you are not familiar with those tools. I'll give you a little bit of background about that. So this particular client, they are a large international client, and they've been around for a little bit, and they came to us for a few different engagements, one of which was to digitize some paper products they had, as well as bring together sort of all of their data together. To talk a little bit about that, they had a core legacy app. It's a PHP app with a MySQL database. So one aspect that we had to work on was just to migrate from MySQL to Postgres. Another aspect, like I mentioned, is they had an existing Salesforce instance, but as part of this engagement, they kind of expanded that, sort of upheaved that with our help to get it in better shape. And they used a package with Heroku called Heroku Connect. Heroku Connect essentially is a data sync layer in and of itself. It is a package you can add on if you're using Heroku. It's called an add-on, and it will essentially instantiate a schema in your database under the namespace of Salesforce. So many of you may know, Rails default apps are under the public schema. It'll actually instantiate another schema under Salesforce and create migrations for you for the objects that you want to sync for Salesforce. It's a very high-level overview, but keep that in mind. I'll come back to that. Then the couple main players, once my team was engaged, are the core Postgres database that, like I mentioned, we had migrated from MySQL. And some of the work that we did, we had written a Rails API around that database that some of the other integrations can work with. So what they kind of look like all together, sort of connected, like I mentioned, they've got Salesforce. That might be where they are working with customers. Some of their sort of like products that they sell, it's their CRM tool, right? Heroku Connect, like I mentioned, provides a sync layer in and of itself to the Postgres database. And then we've got sort of these other handful of apps or engines that we built that also interact with this core Rails API. So keep this diagram in mind. We'll come back to it and see how it expands. So with that, when we were engaged, I mentioned that Heroku Connect already provides a sync layer. So maybe all of you guys are like, oh, cool, your work's done. You've done it all. It's already syncing to Salesforce. Well, not so fast, because the core database that I have been mentioning had a lot of legacy data that didn't exist in Salesforce. Some of that data they did want in Salesforce, but not all of it, for instance. So Heroku Connect wasn't going to solve for all of it. The other really key important thing to think about is that legacy app that I mentioned, the PHP one, is actually a direct consumer of the database. It does not interact with our API at all. So this is really important to know as I get into some of the approaches that I explored. So the first approach I explored to understand if data's changing, how to go ahead and propagate that down to the other side was Rails callbacks. Rails callbacks provide a nice DSL for kicking off another service or logic once something happens in the database, right? Some of the common ones you might see or use are after create, right? After you create a record, after you update a record, after delete, and there's several others, right? And you can have some flexibility around whether it's before or after, whether it's sort of the actual transaction or the commit itself. So there's a lot of flexibility, and that DSL is really nice. And it's Railsy, right? Where I'm working in a Rails API. That's where I'm trying to write my sync layer. I love Ruby, and I want to do it all in Ruby and Rails. Well, teaser up here, that didn't really work out so well because I mentioned two things. One, that PHP Act was a direct consumer of the database. It is not going through our Rails API, and that means it is certainly not going through Active Record. It is never hitting these callbacks. Turns out, actually, Heroku Connect does the exact same thing. When you add Heroku Connect onto your Heroku application, it's actually making direct commits to your database. It is also not routing through Active Record or any of the sort of Rails logic you may have put together. So these callbacks actually never got hit by anything that wasn't using our API. Okay, well, it's not going to work out. So I need to know, when is something changing so that I can go do things, right? If a user is created in Salesforce, I need to make sure that we're getting a user created in Postgres with all those same attributes. Rails callbacks isn't really doing it for me. All right, so the next approach that I tried was sort of like a polling scheme that I tried to write by hand. Now, what I mean by polling in this case at a very high level is I can write sort of like a cron job, and there's a lot of really useful gems and programs you can use to help that, such as the clock gem, right? You can make something run every second, every minute, so on and so forth. And I could write some scripts that sort of look at the database periodically. I could use some proxies, such as like timestamps, to understand if something was created. I could do counts. I could maybe use some other indexes that might be unique. But I would kind of have to find a pattern by hand that would work for all the objects that we're looking to sync, and I'd have to write it by hand. Ooh, that seems pretty dangerous. There seems like there's a lot of unreliability there if I was trying to really capture all the minutia that could happen if I'm trying to pull the database to understand if something changed. And on top of that, it's pretty expensive to keep querying the database like that, right? I don't need to look at a user table with millions of records every time to understand if a new row got inserted, right? There are other tools out there, spoiler alert, that do a much better job of that. But as I was working on this polling infrastructure, what I actually realized I was looking for was kind of both of those two things. I wanted to understand when something changed in the database, like a callback. And I wanted to sort of, the polling really made me thinking of like listening and notifying, sort of like a pub sub scheme. And maybe some of you are familiar with some of the other ways to implement that. And that's how, with a little help from my friends, some of my teammates, when I sort of described, this is what I'm looking for, we stumbled across Postgres triggers with listen notify. So I've got a bit of a teaser up here. So Postgres triggers, these are our database level callbacks, and the listen notify is sort of that pub sub scheme that I keep kind of alluding to. Turns out this is actually what Heroku Connect does under the hood. I'm assuming from all my experience with it. It uses sort of like Salesforce's streaming API, and it creates triggers as well to like listen for changes. Additionally, one of the cool things about this is that because this is at the database level, this meant that I could use it for any consumer of the database, regardless of whether they were coming through Rails or not. That was really cool. That was exactly what I was looking for. This also meant that, as opposed to polling, I knew that I could dictate exactly when something happens. I could let Postgres tell me if something changed the database. I didn't need to query for it or figure out all the nuances there. And I could also decouple a little bit of, despite wanting to use Rails code, I could decouple a little bit of what I was essentially looking for, which was database changes, from all the sync logic that I ultimately wanted to write. And I could leave all of that in Ruby and Rails, which is a really great place to be, in my opinion. We ended up going down this route. One thing I will point out, as you guys will see as I go through some examples, is that generally like this does require writing sort of like the raw SQL. There are some gems and some libraries people have put together to kind of help you work through that. There's actually even a gem that tries to marry the idea of a callback and has like a Ruby and Rails like DSL for using triggers. I did explore that gem. It's called Hair Trigger. Maybe some of you have come across it. But I had a hard time just being as nuanced as I want, which is, I didn't ultimately pursue it, but certainly encourage you guys to explore it. All right, so what are these things actually, and what do they look like? All right, so PG triggers. So as I mentioned, a PG trigger is essentially a callback, much like a Rails callback, all the way down at the database level. That callback can go ahead and execute a function that you write, and that function is written in SQL, sort of with the trigger. You can tell it to execute that function around certain operations, so the insert, updates, and delete. And you can also specify what table it might go on. And when you execute that trigger and that function, you also receive a lot of metadata about that operation. For example, and I'll show some examples, is that you can, it'll tell you what schema was on, so that was important, because as you remember, Heroku Connect actually instantiated another schema for us, a namespace under Salesforce. It can tell me what table was operated on, and it will give you some metadata about the actual record and even give you the sort of the new and the old. It kind of gives you the before and after changes, which was really, really nice, particularly when something gets deleted, and I still need to know what that thing was. All right. And I've got plenty of resources to read a little bit more about that, but that at a high level kind of sums up what Postgres triggers are and kind of what they might be used for. So with that, this is an example of like what a function might look like. So some keywords here. Let's see if this pointer is going to do what I want. You can just create a function or replace it. You want to give that function a name. You can also define, like, sort of store the function of variable. I highly recommend making these the same name if you don't have too many of these, so that you're not accidentally misnaming something later, which I may or may not have done. Here's some of the keywords that I kind of pointed out. So for instance, TGOP, that's the operation. And like I mentioned, that's insert, update, or delete. You can use sort of conditionals, of course. And you can do all sorts of things. This particular simple example is you can even do more things with the database. You don't have to just kick off another service. You can actually do things to the database right at that time, right? You can insert into a table some information, and here's that example of like the old ID, for example. This user got deleted, but maybe we have an audit of users that got deleted. I don't know why. But maybe you want to capture that ID and that some of that information for posterity, so that was really nice. And then maybe if it's not a delete, maybe you're treating create and update the same. You don't care too much. You have this sort of new keyword to know what was the new version of that record. And then you can kind of, and then you want to also like return sort of the record or the operation that happened. And then you can sort of like retell it that you have this like variable name. So that's what a function looks like. Now, how about the actual trigger? So in this example, to actually like apply the trigger, you have some more keywords here, obviously the trigger itself. You can give the trigger a name, and maybe this name is a bit more specific to the table you're working with. If you noticed in the previous example, it was sort of just process function. It was process record is very agnostic, because you can always apply functions to as many triggers as you want, as you can see here. So you're going to tell it ultimately the function that you want to execute. But most importantly, here's where you kind of let it know when you want this trigger to fire, what table you want it to fire on, and then this sort of last bit for each row. So that would be sort of like it says here, anytime like sort of a row is touched. There is also an alternative called for each statement, which sort of executes it one time for like the whole table. In this case, because I'm interested in an individual record and when it changed, I chose the for each row. So you'll see that in the examples. All right, so that's kind of the trigger itself and how you kind of connect them. So we'll get back to that with once we see it all together, but a slight change into what are notify and listen with Postgres. So as I mentioned, it's like a pub sub scheme, essentially. Postgres has a notify keyword or function that will broadcast a notification to a channel. You can define the channel name right there, and you can define what that payload looks like in any way you want. I will note that it's a string, so keep that in mind. But you can do lots of great things with strings and interpolations. And listen, then, is a keyword that Postgres offers. On the other side, that's going to actually be listening to that channel. So you'll sort of say, hey, listen to this channel that I had defined with my notification. And when that notification comes in, you can then go do things with your payload. And all of that you can do in Ruby. So here's what it actually looks like. So pgnotify is the function, the actual function. And like I mentioned, you can give it a channel name, right? Like I said, maybe I don't care about the difference to create an update. Maybe I've got one channel. And like I mentioned, it takes a string, but you can sort of get crazy and hacky If you like hashes, if you don't. But with a hash, you can also do some like transformations in Ruby. So I tended to go that route. And I'll show you in a minute how you can actually like interpolate some of these variables, but this is just a very simple example of what broadcasting that notification might look like. All right, so on the listen side, and this is sort of the Ruby bit, I didn't give just the small Postgres bit. But what's happening here is, I'll just jump for the listen. So this is kind of where I was saying this listen keyword. So this, again, is sort of like raw SQL, right? And I'll sort of talk about these other Ruby elements. It's listening for that channel. And it sort of gives you, when you're within the connection block, it also exposes some of the metadata about that notification. So the channel name itself, the PID, if you need to do something with that, and lastly, the payload. So to back up just a little bit and how to put it all together with Ruby here, we've got quite a few interesting things here. So first of all, to get back into Ruby, you can sort of make a direct, open a direct connection to Postgres with Active Record. Many of you maybe have done this in other areas of your app. And then using the Postgres adapter, in our case, because we're using Postgres. You can also sort of be dynamic here, but essentially you'll start this infinite loop here so that it's sort of always listening. And you obviously want to be careful of that, as we'll talk about. This sort of wait for notify is sort of like a Ruby wrapper around Postgres's to sort of like expose these elements that I talked about. And like I said, this is sort of the magic behind the scenes in terms of like listening for that notification. And then you can go ahead and do stuff. And like I said, you can do all that stuff in Ruby. You don't have to do it in SQL, which was the best part. Last year, you'll notice this in a big like begin block. So one thing you want to note is that you want to make sure you disconnect the listener itself should something happen to this connection, right? You're sort of manually working with a database connection here in Rails. So if something were to happen to that, there's just like a timeout, whatever it may be, these things happen. You want to actually like uncheck the listener so that you don't have these like orphan threads kind of hanging around and you may sort of like lose some notifications or have a hard time finding where they are. So if something happens to the service itself that's running this, this insurer will sort of catch that and detach the listener in that way. All right. So we've got this payload, we've got this notify and listen. Now we've seen some examples of those. And this is just a short sort of show you what a listen was. So on the right-hand side, I've started a server and started opening that connection. And then on the left-hand side, I'm just in the Rails console just creating a user. I happen to be using Rails, but like I said, it'll work for any database connection. And you can sort of see that it is, on the right-hand side, broadcasting the notification that came in, sort of that class name, the CRUD method, and the record ID. This was really fun to watch when I got here. So, all right, so let's put it all together, almost. Let's see how you might use pgnotify within the trigger function. So you can kind of just put it right in there, right, since you're already working with SQL. And like I said, you can start to use all of the metadata that Postgres gives you. You can, this is, I don't know if how many of you sort of like write raw SQL, but this is just a way to do string interpolation. I know it looks like the Ruby OR, but it's actually string interpolation to make this, this gross hash that I have that I use later. But you can see I use some other elements here, like the table name. In the project that I worked on, I used the schema name as well to understand what direction it was coming from, and grabbing the IDs and things like that. So that's using notify within the function. And last but not least, I need to get this in the database. Well, good thing you can write SQL in Rails migrations. Like I said, that is the downside of this approach. So this is certainly maybe a little hairy for someone that doesn't spend a lot of time in SQL. But once it sort of came together, and there's a lot of wonderful resources on the internet, it came together really well. So you can sort of execute that SQL, put all that function together. This is sort of, I have the delete and the not delete version. You want to apply that trigger. And if any of you were to talk this morning, maybe you actually want to decouple these two and put them in 2 different migrations. Or you could, just so you know, like also, I could have another table here. I could do create trigger, accounts trigger, right? And then I could apply this same function, but to the accounts table, for example. And one thing I will point out that I didn't have space in this code block is I chose to do the up. You will want to have like a down migration, and all the down migration has to do is just drop the trigger. So there's a Postgres keyword, drop trigger, much like create trigger. You want to do that, and it'll just sort of like roll this back and just not apply the function. So again, like the function is sort of one element, and then the trigger is one element, but they are often used together because you want to kick off a function once something happens. There is another gem that I actually discovered after I did this work, but I'd be curious to refactor, called FX. And that gem is more opinionated about actually splitting up functions from triggers in different migrations, and they actually will generate SQL files for you instead. And then once you get to like the actual Rails migration, you sort of just have some nice keywords like create trigger, and then you sort of point to the SQL file that you wrote the trigger in. And that's a nice way to continue decoupling. So that's something I want to continue exploring and refactoring a bit, because I discovered it a little bit later. All right, so I want to just show kind of what that migration will sort of like spit this all out. One thing you'll note is if you're using like schema.rb, it won't show up there. If you change your format to use like structural SQL, you'll actually be able to see, since it actually documents all of the raw SQL for all of your migrations. On a subsequent project that I've used triggers, I actually migrated to using structure.sql so I could better sort of get that feedback loop and know that my triggers and functions have been applied correctly to the database. All right, so putting it together a little bit, back to the use case. All right, so this looks a little bit like the diagram we saw earlier, but I want to show more so the sort of flow of data in this case. So again, we have these sort of two halves, and in reality, actually, this is actually several apps. Some of them talk to the API, some of them talk to the database, but I sort of simplified. So like I mentioned, we have all these different schemas. Incidentally, this client actually had another schema that wasn't under the public namespace, but this worked really well for it. You've got your Postgres database doing all the heavy lifting for you. And then, like I mentioned, I might have individual listeners, so that's why I cared about what schema it was, and I could use sort of the TG schema keyword that Postgres also provides. And then I can go ahead and do whatever I want, right? Maybe I've just got some Ruby code that will, map the attributes and propagate it from one side to the other. So there are some considerations when building any data sync service, but in particular when sort of putting all these pieces together. One is maintaining that connection. So we talked a little bit about the infinite loop. Maintaining a connection in this sense actually means it's recommended to sort of decouple that listener service. It's opening its own database connection. You don't want it to time out just because there's an application error. You can put this in another server or another process. For Heroku, on the proc file, you can just define it. Well, and other systems use proc files as well, but in this example, you can just sort of give it whatever name you want. Maybe some of you are familiar with the web and worker ones. I chose to sort of kick it off in a rake task, but you could also sort of do it directly here if you wanted. And if you are using Heroku, it'll kind of pop up as like another dyno, much like a worker would or something like that. The nice thing about that, and I think this is applicable to AWS or other hosting platforms maybe using, is you can kind of scale this as well, right? If you've got a lot of transactions happening, maybe you want to give it a little more firepower. So there are a lot of benefits to maintaining that connection separate from, say, your web app or even your other workers. All right. The other thing to consider is keeping like a log. This is a very common approach when you're doing sort of like data syncing. You want to know like if you've missed something, or if something does happen, you want the ability to know what you missed and be able to maybe retry that. A very, very simple application of this is to literally make just a small model called a database trigger log model, for instance. And maybe that model catches the payload. You can see here kind of another way to show off like functions. You can build sort of that similar payload that you do in the notify. And like I said, you could insert directly to the database at this point. And this is good because if my listener cuts out, this will still run, right? The database is unaffected by the sort of like dynos or containers that are running. These will continue to happen, and what you can do is, for instance, at a very simple level, maybe my model just has a couple statuses of pending and synced, and it can start in pending, and then once it actually makes it all the way through my Ruby code to propagate all the changes that I want to change, then I will change it to synced. Now, what you can do then is, say the listener cuts out, in that in this sort of like rake task, or maybe you want to add another rake task, the first thing you can do is call a service that says resolve all your pending trigger logs, right? And you can try to like push them through. Now there are many other considerations, a very, very simplified use case. There's other considerations such as like the order of when things happen, like maybe you have some issues there. But at a very simple level, you know, if your system can restart pretty quickly, it's a really just easy, crude way to kind of log all the changes that have happened, all the triggers that interacted with your database, and give them some retries. But that does bring me to another consideration is like you don't want to run into a continuous loop with triggers. So for example, if I am doing a sync process and something happens in Salesforce and I want to bring that all the way down to our user table, well, I'm going to touch the user table under the public schema as well. Well, that's going to trigger another trigger, and we're going to like be caught in this loop. Now, I think you know, there's a lot of like Rails magic that you know, with caching that may or may not actually like commit it, but I didn't really want to rest on those assumptions. I want to make sure that I was not caught in an infinite loop of triggers of something updating the other. As you know, like the timestamps will always change, so you can be caught in this loop. So you'll actually want to disable those triggers when you're actually doing your work. So for instance, I have a function called commit without trigger, and it takes a block, which is sort of like the actual work, right? The mapping and the updating of certain fields. But once again, and wrap this in a transaction, once again, you want to open that connection directly. And you can sort of execute this raw SQL again with the disable trigger function here, keyword. You can go ahead and do your work. That's what this yield tap return value bit is. And you don't want the triggers to be disabled for too long, right? Because there's going to be other things coming to the database, and you don't want to get caught in a situation where you've actually missed that notification. So the minute I sort of know what work I need to do, I want to go ahead and enable those triggers once more. And then, as I pointed out, you know, I want to update that trigger log to say that we have successfully completed our sync. There are a few other options to this. As I mentioned, like a big concern is the fact that you actually could get caught missing a trigger. This all happens fast enough that we personally actually haven't noticed this. But another option is to use, set the session replica role to replicate. And that is also sort of like another way to prevent triggers happening because you're sort of doing it under this other role. And there's some other options too. You can sort of change the user in line here and a lot of different options. This is the one that we sort of stumbled upon first and kind of made sense. It was pretty easy to understand and work with. All right. Okay, so lastly, I sort of alluded to this, but aside from just working with triggers and notify listen, there's just general data syncing considerations, right? For instance, you want to identify your dependencies and conflicts. I sort of mentioned before, you want to account for being able to retry, but you also actually want to account for any race conditions that either might happen in the retry, or for example, that might happen with parent-child relationships, right? Perhaps the parent and the child got triggered at the same time, but for whatever reason, or sorry, got created in their respective databases in the same time, but may not have quite gotten to the trigger at the same time. For instance, the child could have got there first. So you want to account for that. You can implement sort of just a retry flow on your own that says, hey, if my sync service failed, go kick off this retry job. Maybe by the time you circle back, this parent will have come through, right? So that's a big one, is some of those associations and maybe other dependencies that you might have in your system. And lastly, of course, right, test it out. Of course, you can test it in the console. You can check out your structure SQL. You can see all these things happening. But you obviously want to write your automated tests. You might use unit tests for your actual sync logic, right? Did I map my attributes correctly? Am I sending it to the right place? But you also might want to write some integration tests. And in this case, an integration test might actually start all the way at the beginning, where you insert a record in your test and let the trigger fire, let all the services fire, and see that come all the way through and make sure that the thing that comes out was the thing that you were hoping to update. And that was it. I made it on time. So I've listed a bunch of resources here, but yeah, thank you guys so much. I guess we have like maybe 30 seconds for questions, but yeah. Yes. Yeah, the question was whether I've ended up having to use sort of like raw SQL a lot as I built out this data sync layer. I will say I most had to use it to write those functions. those gems I mentioned sort of help, but maybe if you need more nuance, you'll want to write the raw SQL. But one of the big drivers of this whole process was to get me back into Ruby land so I could write the rest. So the actual sync logic, which I didn't talk about at all, is all in Ruby. Cool, thank you.